We're going to continue our discussion on domain and range in page 10 of your orange packet. Pause the video if you're not there. Of discrete functions. This is continuous functions. It's continuous because the dots are connected. So the first question it says is, can you see the whole thing? And what I mean by that is at the end of the graph, if there were an arrow, then that piece of the graph would continue on and on forever, and we wouldn't be able to see the end of the graph. In this case, we can see the whole graph. So yes, we can see the whole graph. And if you can see the whole graph, that means we can essentially box it in. So when we can box it in, we can see all of the different points that are included in this graph. So if I go to the x-axis and I box it in, this is the farthest the x goes. Okay, up to the top, go all the way across until you're even with the last point here. And we're basically just drawing a box around the graph. Okay, like so. That's the entire graph. So when we do our domain, we're going to do it as a range of values. So domain, which is our x's, are all of the x's in between. And when we did in between before, we did it like this, with the two inequalities facing the left. So you're going to tell me what values can x roam between. So the x-axis is here, so you're going to give me the numbers that x goes from on this line. So the smallest x number is -6. So this graph lives between x is -6 and x is 7. This would be 7. So that's our domain. It's from the smallest to the largest x values where this graph lives. The range is going to be the same thing, but it's going to be the y values this time. So y goes between what two values? So the y values, that's going to be on this axis. So what's the smallest x can be? That's going to be right here. Y can be, sorry, it's -7. That's the smallest y value that shows up on this graph. And then what's the biggest y value that shows up on this graph? And that's +7. And that's your domain and range. So if it can be boxed in, we're going to box it in, and then you just tell me what is the smallest x and biggest x, smallest y, and biggest y. And that's where this graph lives in between. So the domain just means all of the possible values for x. X can be -6, x can be -5, there's a dot there, -4, -3, -2, there's dots along all of those x values from -6 all the way up till 7. Okay, same thing, can you see the whole thing? If you can see the entire graph, then that means we can box it in. So we're going to go from the top of this graph, or you can start on the right of this graph. So the right is here, and we're going to actually box it. Don't curve with the curve of the graph, and don't go past where it is. Okay, and then you're going to go on the x-axis for the domain. So the domain is any x value between what two numbers on the x-axis, and the range is going to be between what two numbers on the y-axis. Okay, let's do the x-axis first. So I can see on the x-axis, I can see that it hits -4. -4 is the farthest it goes. And then here's 0, 1, and then this must be the number 2. So from -4 to 2 is where this thing lives on the x-axis. And then the y-axis, the farthest down it goes on the y-axis is -6. And the farthest it goes up on the y-axis is, looks like that would be the number 4. So -6 and 4. So when we can box the graph, that's pretty simple. It's pretty self-explanatory. When we can't box in the graph, that's when it gets to be a little bit more complicated. Okay, so this one says, how many arrows do you see? So if you look really close, this is a dot right here at -4. But on this side, it's an arrow, so it keeps going. So if I were to try to box this in, I could box this side. I could stop it on this side. I could stop it up here, but I couldn't stop it here because I would have to keep moving my line out further and further and further as the arrow pushed my line out. So this arrow kind of tells us that we don't have a side of the box over here. So we can't actually box it off here. So we could box on this side. We could box on this side. But the other two sides we actually can't box. So how would we write that out? Okay, so let's talk about the domain. The domain is any x values between, okay, and I do have the right side of this graph has a number. Okay, so the right side, that number is 4, and I can put that number here. But it doesn't stop on this side. So this would keep going until negative infinity. It would just keep going forever. So you actually don't have to put a number on that side, and you don't have to put a symbol either. So that's your domain, any x's from 4 on down. And then the range, this is where it gets to be a little bit trickier, because trying to figure out if you have the top number on the bottom number on the graph. So this is the top of the graph. The top of the graph always goes on this side, and the top of the graph is at 2, and I don't have a bottom of the graph because I can't stop the graph here. That arrow will keep pushing my line down further and further, so I actually don't need this either. So there's your domain and range. So if it only has one arrow, if you see one arrow, you're only going to have one number here. Okay, whether it's the top number or the bottom number, right number or left number is a little bit different, okay, depending on how the graph looks. So the same thing here, let's do domain first. And I'm going to set it up the same. I'm going to go x is between so that it's easier for me to set up. And then I'll just cross off the one I don't need. It could be this one I don't need. It could be this one I don't need. And then the same thing for the range. And here's the arrow. I just want to make sure to myself that I know where that arrow's at. Okay, so x should have a right side and it should have a left side. I can tell you where the right side of this ends. It's right here at 6. But this left side, because of the arrow, would keep getting pushed back and back. So I can't stop it at any one number on that side. So my right side is the number 6, but that just means I won't have a left side. And that's okay. This time with the y value, I have the bottom of the graph, but I don't have a top. And it seems like this would be the top, and that's a little bit confusing. So here's the bottom of the graph. And it seems like there would be a top here, but when this arrow keeps going on forever, it'll actually be higher than this dot. So that dot right there is actually not the top of the graph, even though it kind of, you really want it to be. This bottom number of -2 is actually going to go on this side because the bottom goes on the left, and I don't have a top this time. Okay, now if we need to kind of write that out, I can do that over here on the side. If you can see the whole thing, you should be in between the x. The x is between the number on the left and the number on the right. The y value is going to be between the bottom number and the top number. So if you needed to have that out on the side, just to kind of remind yourself, if it's the number at the bottom of the graph, it goes over here. If it's the number at the top of the graph, it's going to go over here. Same thing, right and left. Okay, what if it has 2 arrows? What if both sides of the graph have arrows? What is that going to look like? So that's our last 2 examples here on the bottom. We see 2 arrows. So this arrow goes this way. This arrow goes this way forever and ever. Okay? One of your x's or y's is not going to have a number at all, but we have to figure out which one that is. Okay, so we'll go domain, and we'll go range. The domain is x between, the range is y between. Okay, so x is supposed to be the right side and the left side of the graph. So can you put a line here and stop the graph? No, because that arrow is going to keep pushing you on and on and on. This arrow is going to keep pushing you this way. So if I don't have a number on this side and I don't have a number on this side, what does that mean? That actually means that every number works. So if you go to infinity on the right and you go to negative infinity on the left, that means every single number works for your domain. So instead of writing it out like this, we just get to write, this is a super fancy R, it's called all real numbers. All numbers work. Okay, you say this, right? This is called all real numbers. Or you could write out, if you wanted to, all real numbers. So how come the range isn't that way? Because on the range, I can actually put a line at the top of this graph. I can box in the top of this graph because it doesn't go any further than +2. That is the top of the graph. And up here, we wrote that the top of the graph goes on this side. So the top number 2 goes here. And we don't write anything over here. Okay, so when there's 2 arrows, one of your either domain or range is going to be all real numbers. Okay, let's try that again. So I'm going to set up my domain. I'm going to set up my range. X is between. Y is between. This time I actually can box in my X. The left side of this graph ends right here. So if it ends, I can figure out where it ends. It ends at -2. So -2 is the left side of the graph, so I can put that here in my X, but I won't have anything on the right because I have 2 arrows on the right. Okay, so if this one isn't all real numbers, then this one is probably going to be all real numbers. And the reason is I can't put a top on this graph because that arrow is going to keep pushing it. I can't put a bottom on this graph because the arrow is going to keep pushing it down. So it's going to go up continual until infinity. It's going to continue on and on and on until forever. And then it's going to go down forever. Well, instead of writing it out like this, we just write that all numbers work. That's a lot simpler than writing it like that. Okay, that's your page 10 notes. To go with this page 10 notes is classwork pages 1 and 2. So the first and second page of your classwork should already be completed. We did page 1. This is like yesterday's work, where the points are discrete, the values are discrete, the graph is discrete. And then on page 2, you'll see the continuous functions like today. Okay, page 1 and page 2 are your practice work for the rest of the class period.